Alright, welcome to 7-1, solving equations with the variables on each side, and that is our objective. We're going to have equations like the one we have here where it says solve 2x plus 3 is equal to 3x. After we solve and find out what x is, we're going to check our solution. Alright, so you do notice that there are variables on the left and the right side of this equation. We need to move one to the other side. I always like to move the variable with the smallest coefficient, so that would be the 2x. As you can see, I'm doing that to both sides. I cancels out here, I'm left with 3. 3 minus 2 is 1, so I get x is equal to 3. Now it's time to check our solution. Alright, when it says check your solution, that's part of the directions, and this is what we got to do. We want to make sure that x is equal to 3. And so what I did was, wherever there's an x in the original equation, I plugged in 3. And I'm just going to simply go ahead and solve on the left side and on the right side. So you can see 2 times 3 is 6. I'm going to add 3 to it. On the other side of the equation, I had 3 times 3 and it's 9. I know that 6 plus 3 is 9. So it does check out. My answer is x is equal to 3. Alright, on this slide you see that we still have an equation with variables on both sides. We have a 5 and a 3. My objective, of course, is to move the x to one side or to the other. I like to take the x that has the smallest coefficient, that is the one with 3x, and move that to the other side. You can see that this cancels out. Alright, I have negative 2x on the right hand side. 5 minus 3 is 2x plus 4. And now I have an equation that's a two-step equation. So I want to isolate the x. So the first thing I'm going to do is reverse PEMDAS. So I'm going to subtract 4 from both sides. That cancels out, gives me a 2x. A negative 2 combined with a negative 4 gives me a negative 6. Here's my last step. I want to isolate the x, so I want to unhitch the 2 by using the inverse of multiplication, which is division. I am only dividing by 2 because I want to isolate the x or keep it where it's at. That cancels out, and I get x is equal to negative 3. Now it's time to check my solution because it's part of the directions. You see that I took the original equation. Wherever there's an x, I put a negative 3 because that's what I assume the answer to be. X is equal to negative 3. And I'm going to check to see if it's true. I'm going to go ahead and simplify both sides. I got 3 times 5 is 15, negative 15. Negative 15 plus 4 is negative 11. I'm going to go ahead and do the other side of the equation. 3 times 3 is 9. Positive and negative give me a negative 9. I'm going to go ahead and combine a negative 9 and a negative 2. That gives me a negative 11. Yes. My answer is x is equal to negative 3. Alright, we have another equation. Solve 2.4 plus a is equal to 2.5a minus 5. I'm going to go ahead and continue with my same method. I'm going to move the variable first. I am going to choose the variable with the smallest coefficient, and that would be, of course, the a. So I'm going to go ahead and subtract a from both sides. I want to make sure I line up my like terms. That cancels out. I'm left with 2.4 is equal to, and I got negative 2.5 minus 1 gives me a 1.5a and minus 4.5. Now that I've combined my variables to one side, now it's time to isolate that variable. I'm going to go ahead and move or use reverse PEMDAS, and I'm going to do my addition first. That's going to cancel out. Whatever I do on one side, I do to the other. I'm going to go ahead and add 2.4 and 4.5. I get 6.9 is equal to 1.5 times a. Notice that the variable is still not isolated, so I'm going to go ahead and divide, which is the inverse of multiplication. Notice I'm only dividing, of course, by 1.5 because I want to isolate the a. Whatever I do on one side, I do to the other. I check my calculator. 6.9 divided by 1.5 is 4.6 is equal to a. And once again, I got to check my solution. You can see wherever there was an x, I substituted 4.6 into it. I'm going to go ahead and solve both sides. 2.4 plus 4.6 is 7. 2.5 times 4.6 minus 4.5 is 7. There it is. It does check. My answer is a is equal to 4.6. Alright, we're going to continue on. We notice that this equation has variables on both sides, but it poses a unique problem, of course, with a fraction on the left side. What I'm going to do is, the fraction is a division problem, so I'm going to use the inverse, which is multiplication. That's why I brought out the parentheses. We're going to take the reciprocal of this fraction without the x, so that would be 0.4. And the rule is that if we multiply by reciprocals, we get 1, or 1x. Now we're going to do the same thing to the other side. We are going to multiply by a 0.4. But as I said in the past, we don't just do to one, we do to all. So how do we represent that in math? We put our 2x plus 1.2 in parentheses. And that reminds us that we're not only going to multiply to 2x by 0.4, we're also going to multiply 1.2 by 0.4. Alright, so this is what we get, 0.8x plus 0.48. Now that we only have no denominator anymore, we're going to go ahead and move the 0.8 because it's the smallest coefficient in front of our variable. So I'm going to subtract. Whatever I do on one side, I do to the other. Notice I'm lining up like terms. This will cancel out. A 1 minus 0.8 gives me a 0.2x is equal to 0.48. Now, the x is still not isolated. I have to remove the 0.2 by using division. Notice I'm only doing the 0.2, leaving the x to be isolated. X is equal to 2.4. Alright, now I'm going to check my solution. I am going to plug in 2.4 because that's what I think the x is equal to all the x's. Now I'm going to plug in chug. I'm going to go ahead and solve the left-hand side. And the left-hand side, 2.4 divided by 0.6, or 0.4 is 6. Then I'm going to go ahead and get rid of the parentheses, or simplify the right side. I get 4.8 plus 1.2, and that does equal 6. So that means 2.4 is the solution for x. Alright, what we have here is a word problem. We're going to define a variable and write an equation to find the number. So here we go. Twice a number is 220 less than 6 times the number. What is the number? Alright, let's break this down. I see that I get twice a number. Then I have the is, which represents the equal sign. And so twice a number is the left-hand side. Twice means to multiply by 2. And I don't know what the number is, so I'm going to use a variable to represent that. Is equal. Now I'm going to go to the right side of the equation. I get 220 less than 6 times the number. Right, less than tells me I am subtracting, but it also tells me that, of course, that 220 is doing the work. If you remember back when we first started translating, whoever's doing the work comes second. We put whatever work they're doing, or whatever operation, which is subtraction, first. And the number that is getting the work done to them, which happens to be 6, times the number, and once again we're using x to represent the number. You can see here that we have 2x is equal to 6x minus 220. Alright, this problem is a little bit different. Normally I take the smallest x, our variable with the smallest coefficient, but I'm not going to do that because it'll provide an extra step. I'm just going to go ahead and move the 6x to the left hand side so that we have one variable. You can see this, the 6's cancels out. I get a negative 4x is equal to negative 220. Now I'm going to go ahead and isolate the x by dividing by a 4, but not just a 4, a negative 4, because I want to make sure that my x stays positive. Two negatives make a positive. I'm going to do the exact same thing I did on the left side, which is divide by 4, divide by that negative 4. Two negatives make a positive, and 220 divided by 4 is 55. That is the answer to our word problem. Alright, we have a word problem. We have a video store has 2 membership plans. Under Plan A yearly membership costs $30 plus $1.50 for each rental. Under Plan B, the yearly membership costs $12 plus $3 for each rental. What number of rentals results in the same yearly cost? Alright, the big thing here is to define our variable. Alright, in both of these, we're wondering what number of rentals are we going to have. We don't know how many videos we're going to rent, so that is the unknown. So we're going to use X to represent that. How many things are we going to rent? Well, what they told us that there are 2 plans. Plan A, which I was told the membership is $30, plus for each rental, that's X. I don't know how many I'm going to rent, but it's going to cost me $1.50. And in order to find that cost, I'm going to take that $1.50 and multiply it by each time I rent something. Then Plan B, sort of similar. I pay $12 for the membership, plus, depending on how many I rent, $3. In order to find the cost for this one, I take 3 multiplied by the number of times I rent. Now they want to know what number of rentals result in the same yearly cost. Well, same are equal to. So we made both plans equal to each other. And what we're going to do is find out what X is. We got variables on both sides. I'm going to go back and use the X that has the smallest coefficient, which is $1.50. Notice I am subtracting both the coefficient and the X. Whatever I do on one side, I do on the other. I'm lining up like terms. Over here, that cancels out. I'm left with 30 is equal to 12 plus, and I have 3x minus $1.50 or 1.5. That gives me 1.5. Now I have the variable on one side. Now it's time to isolate it. I'm going to go ahead and do reverse PEMDAS. So I'm going to take this positive 12 and I'm going to subtract 12 from both sides. Alright, that gives me 18 here. This cancels out. I have 150 x. Now all I got to do is isolate this x. So I'm going to go ahead and get rid of the 150, but not the x, because I want to isolate it. I want to keep it where it's at. Whenever I do it on one side, I do the other. Alright, so I have x, and then 18 divided by 1.5 is 12. And of course this is a word problem, so this is rentals. So Plan A and Plan B are the same cost if I rent 12.